As I was saying, one important application of derivatives in calculus is particle motion. So we will talk a lot about a particle. A particle, this particle, he doesn't get to zigzag around and do all kinds of crazy things. So it's kind of physicsy, but we scale it back a little bit for math, and we have a whole lot more restrictions, and we ignore some things sometimes. So this particle, whoever he is, he either gets to go left and right, or he gets to go up and down. But he doesn't go in circles or side to side. You know, it's either left or right or up or down. That's it. Okay? So two directions, and that's it. One or the other. The three equations that are important when working with particle motion are position, which is most of the time, or if we, I say most of the time, if we are going to write it from scratch, or we are going to use something like that, it's going to be S of T, S being position, not P for position, S. Why? Because I said so. I don't know. It's just because it is, all right? Then position, what comes after position? Anybody know? Velocity. Velocity, okay, which we can represent as V of t, and when we do, that is the exact same thing as S prime of t. So velocity is the derivative of position. Make sense? Okay, position, velocity, then what? Acceleration, good. Acceleration. So this is good. Oh, that's all one word. Acceleration. That's A of t, which is the same thing as S double prime of t, which is actually the same thing as V prime of t. Sorry that I wrote so big. Can you read that? Let me rewrite it. Oh, no, that's not what I meant to do. I shouldn't have written so big. So that's A of t, which is V prime of t, which is S double prime of t. There you go. All right, so listen, we got position. Velocity is the derivative of position. Acceleration is the derivative of velocity. So we got acceleration, it's the derivative of velocity, which is the second derivative of position. Okay, make sense? PVA, so we abbreviate particle motion. Particle motion is what we talk about, but we also call it PVA for position, velocity, acceleration. Now, speed and velocity, those words sometimes are used interchangeably, but they're not exactly the same, okay? If I am driving down the road, I can drive at 65 miles per hour. I cannot drive at a negative 65 miles per hour, right? That doesn't make any sense. However, I can have a velocity of 65 and a velocity of a negative 65. So when we're talking about speed and velocity, they are not the same. They are used interchangeably sometimes, most of the time incorrectly. But the speed is the absolute value of velocity because velocity can be negative. Okay? In physics, we say that speed is a scalar and velocity is a vector. It has a direction. Okay? And so if these words right here, scalar and vector, are giving you a little anxiety right now, don't worry, we probably won't say those again. Well, good with that? So can you have a negative speed? No. Can you have a negative velocity? Yes. Are speed and velocity the exact same thing? Frida, pay attention. Okay. All right, important notes in calculus AB, which is where you are. All motion is considered rectilinear. Sounds a little terrifying, but okay, meaning motion only happens along a straight path. Okay, that's what I was saying. It's horizontally or vertically. We're either going left or right or up or down. That's it. We're not going diagonally. We don't get to go in the squiggly lines, nothing. Okay? BC will later look at 2D motion, but we're not. Okay? I'm sorry, what? Okay. So with this, you are either, so if we have a particle and I have a little X and Y axis, either the particle is moving left and right on the x-axis or up and down on the y-axis, and that's where we're looking at our positions are, okay? We're all good with that? If we're moving left, it's related to moving down, so that it's moving towards the negatives, and up and right is moving towards the positive numbers, okay? Just to make sure we understand all this. All right, so Questions involving motion are common on the AP exam. Like, you are guaranteed to have some of these. All right, we will need to be able to use these equations and take derivatives as needed to answer questions involving motion. To answer questions on particle motion, we will need to be able to decode questions into math equations. Consider the following phrases. Okay, so we have the bug is stopped. Okay, if the bug is at a dead stop, then does that tell you anything about its position? Does it tell you anything about its speed? Yep, it's not, the speed is 0. If I'm stopped, I'm not going, there's no speed there, right? So v of t, whatever it is equal to 0. Okay? So to solve it, that means you just set v of t equal to 0 and solve. Okay, so if it's stopped, that should tell you my velocity is 0 when it's stopped. That gives you something. And things being 0 are usually pretty helpful. Okay, if we're moving to the right, and in parentheses, I want you to put up. So it could be to the right or up, either one. Then that means your velocity is positive. V of t is greater than 0. Positive. Right? And if I want to know if something is positive, I set v of t equal to 0 again, and use sign chart. Remember the sign charts? Okay, and y'all are going to have to forgive me. Have we done sign charts again in here yet? No? Okay. Because we've been doing them pre-cal like crazy, so that's why I'm a little mixed up on that. But sign charts are not that bad. Okay. Use that as an E. That is a really bad E. Okay, so let's talk about what a sign chart is. Use a sign chart. So if you recall, let's just talk real quick about what a sign chart is. So let's say that we have a, I don't know, let's say we have a factored function f of x, and that's equal to x minus 3 times x plus 2 times x minus 5, or whatever, right? So my zeros here, so when I set that equal to 0, my x values are -2, 3, and 5. And don't worry, we'll do a bunch of these. You don't have to write this down, but just kind of trying to refresh your memory. So on my number line, I put -2, 3, and 5, right? And then I want to figure out, and this was, when is it positive, right? So let's say we're trying to find out when f, well, we said v, so let's pretend like this is v of t. V of t is greater than 0. So let's just pretend like this is v of t, even though there's x's, it doesn't matter. So when I substituted in, I picked something between -infinity and -2. Let's use like -3. I put it in here, that's still negative. I put it in here, that's still negative. I put it in here, still negative. So when I I don't care what the actual number is, but any number between -infinity and -2 that I substitute in there, I'll have negative, negative, negative. When I multiply it all together, it's negative overall. Okay, so remember that? Then between -2 and 3, I can pick 0. So when I substituted in here, I'd have a negative number, a positive number, a negative number. When I multiply all those together, it's positive. The only thing that's going to keep it from alternating is if you have an exponent of, so let's pretend like there's a squared here. Okay? So if I did that, that's going to change things up a little bit, right? Look at what happens here. When I substitute in, so I'm going to pretend like these aren't there. I'm going to use purple now. When I substitute in a -3 right here, that's going to give me -6, so that's negative. -3 here gives me negative. No matter what I put in here, I'm going to square it, and it's going to become positive, right? So that last term's positive every single time. So that means my function now is positive here. When I substitute in 0, I'm going to have negative, positive, positive, because again, that one's always positive. That's negative overall. When I substitute in 4, I'll get positive, positive, positive. That's positive overall. 6 will also give me positive, positive, positive. That's positive overall. And notice where that square is, that's where it didn't alternate. If you don't remember those things, it's fine right now. Doing a full sign chart is really not that big of a deal, and sometimes you need to do the whole thing anyway. Okay. So now, if I wanted to say when is it greater than 0, I'm looking for when it's positive. Okay. So my answer would be from -infinity to -2, and then here from 3 to 5, and then here from 5 to infinity. Oops. Do you understand why I had to write these as two separate ones? Because it says greater than 0, right here, this is equal to 0. Okay, so I can, because that's a 0 of my function, right? This is a 0 of the function. This is when it's positive, positive. That's when it's actually 0. Because your function, if we were to graph this, would look like this. Positive, positive, bounce. That's what that would look like. Okay, make sense? So this is why, remember when we were doing these and I said to you, sometimes we don't care what the graph actually looks like. All we care about is it positive or is it negative, right? That's what we're looking at right now. Because if it's if this is a velocity function that I just totally made up, so I don't even know what it is, but if this was a velocity function, then I know that in these intervals, when it's positive, that means the particle's moving to the right. Between -2 and 3, the particle's moving to the left. Okay, does that make sense? If this is a velocity function, tell me what's happening here. What's happening at these points? What's the velocity here? 0, so is your particle moving at all? No. So I'm moving to the right. I stop, turn around, move to the left. Stop, move to the right. Stop, keep moving to the right. Okay, that's what's happening there. Okay, you with me on that? Okay, good. Like I said, we'll come back and we'll do some of those, but that's just at least a good little example. All right, so then if it's moving to the left or down, that is when your velocity is less than 0. So we do the same thing. We set v of t equal to 0 and use a sign chart. We used them really to graph rationals and we did it really after we graphed those or sketched those polynomials, but we did it a lot to graph rationals. That's not really the application of it here, but we do use those a lot. It's still just the same thing, okay? So if the bug turns around, so let's go back to this, right? So the bug was here. The bug is moving to the right. Why can't I get a color that actually works? The bug is moving to the right. Now he's moving to the left. So when he stopped, he turned around, right? And then he's moving to the left. He stops. He turns around. He moves to the right. He stops. Does he turn around? No. So it's not just when v of t is 0, because you can just stop and then keep going in the same direction, right? The way you change direction is when we change from positive to negative or negative to positive, okay? So when you want it, if you know that the particle turned around, whoever it is, whatever it is, it's just a thing. We could name him if you want. But it's when v of t changes sign. And guess what we do? We set v of t equal to 0 and use sign chart. Because you're going to get that same information, right? Just to see, is it, like I don't care where it's positive and negative basically, but I care where it changes from positive to negative and negative to positive. Okay, so then when we speed up, that affects what? Position, velocity, or acceleration, you think? Acceleration. Does acceleration also show up when we're slowing down? It's like a negative acceleration, right? But it's not just acceleration being positive or negative. It is the velocity and acceleration. Goodness, I cannot write. Have same sign. Whatever it is. They're both positive, they're both negative. Doesn't matter. Okay. And so here, basically the same thing, but however you're going to do it, the signs of v of t and a of t. So it's not necessarily a sign chart because I don't care if I'm switching from positive or negative. I just care at that point, is velocity positive or negative, and is acceleration positive or negative? So what do you think is happening when the bug is slowing down? It is deceleration, and they would have different signs. So v of t and a of t have different signs. Okay, so again, we check signs of v of t and a of t. Okay, and I'm going to add something to this out to the side because I wrote too big, and then we'll just put it in there as a group. So right here on all three of these where we said set this equal to 0 and use sign chart, you can put or graph. If you're given a graph, you can tell it from the graph, right? If you're given an equation, you have to do the sign chart. But sometimes when you have a lot going on, even if you have a graph, it's good to make a sign chart, which is easy to do from a graph, but it can help you put things together when you get multiple things going on. I'll show you when we get there, I'm just saying. Just because it's a graph doesn't mean we wouldn't have a sign chart. Okay, we all good with that? Any questions at this point? So we got position is where you are, right? Velocity is how fast you're going and in which direction. That's different. The speed is just how fast you're going. Velocity is how fast and which way. So v of t is the derivative of position, and we use v of t for moving to the right and left, and turning around. Well, if we're speeding up or slowing down, you have to look at velocity and acceleration to figure those out. Okay, we all good? All right, let's go over here. All right, the data in the table below gives selected values for the position in meters and the velocity in meters per minute of a particle moving along the x-axis for t being greater than or equal to 0. The position x is twice differentiable. Okay, so let's think about what that means. Twice differentiable. If x is differentiable, what does that tell you about it? It's continuous. If it's twice differentiable, that means I can do it twice. So when I take here's x, since it's differentiable, I know that it's continuous. Since it's twice differentiable, that means v of t is also differentiable, so that means that they're both continuous. Does that make sense? That's what twice differentiable means. You can do it twice. I would say that we want to make sure that our units are correct. So it tells me the position is in meters. So position is x of t. There's my meters. And velocity is meters per minute. So I'm going to write that out so I don't mess anything up here. And when t is greater than or equal to 0, so I think we're good. Okay. Is there a time in the interval from 0 to 6, which is what we have up there, when the particle is at rest? If the particle is at rest, then what has to be true? Any ideas? V of t equals 0. Okay. So when do you think that might happen? If it is continuous and differentiable between 0 and 3 and between 5 and 6, right? Why? Because it's continuous. And what theorem tells us this? IVT. So between 0 and 3, if velocity changes from 1 to -4, right? Wait, what is it asking me for? When is the particle at rest? Then there has to be a 0 in here, right? If it's continuous, 0 has to be in here somewhere. 0 has to be in here somewhere. You agree with that? Okay. Oh, no wonder. I'm looking at something different. No wonder I'm confused. I was like, this is not right. It's because I have the wrong key up here. Okay, that's okay. That's why I kept looking back at it going, that is not what I'm getting, but I'm going to go with it. All right. So here's what we know. So I want to say yes. So I'm going to say there is a time. Actually, I can say how many times are there? 2. Do we know there's only 2? And there's at least 2, right? Because couldn't it happen here too? We just don't know what's going on, right? So I can say there is at least 2 times on 0. I'm just going to recopy that. Okay. Where actually, let me do this. Yeah, 2 times on it. No, that's fine. We can word this different ways. Because this is what's going to happen. This is what happens to me when I start writing them. I start writing because that's like how I'm going to start it, and then I think, oh, but I need to say this. But then you just change your words as you go. Because yours isn't going to sound exactly like mine, and it's not going to sound exactly like your neighbor's. It's just however it comes out of your head, right? There are at least 2 times where particle is at rest. V of t equals 0 meters per minute since zero meters is between what? 1 and -4? 1 and -4 meters on the interval from 0 to 3. And what? Oh, meters per minute, yes. I was processing meters. That's meters per minute, yes. Units, guys. This is your meters, that's your meters per minute. On 0 to 3 and between -1 and 2 meters per minute on 5 to 6. By IVT. And I really think if you left off the by IVT, you'd be fine, but that's what this is, the intermediate value theorem going in between there. Okay. What I was going to, I think what I was going to change, like is when I was like, oh, I was going to kind of leave out the 0 to 6 and then just talk about the other two, but it's fine either way. Okay. What questions do you have? You good on that? I'm not a big fan of IVT either, I know. All right, particles speeding up or slowing down at time t equals 5. If it's speeding up or slowing down, what do I have to look at? I have to look at acceleration and what? Velocity. So v of 5 and a of 5, right? What is v of 5? -1. How can I figure out the acceleration? I can take the derivative of v of t. I don't have the derivative of, like I don't have v of t to take the derivative, right? And they didn't give me an equation. What? Rise over run. I can find the average rate of change here. You agree with that? Okay. So in order for me to find the slope at 5, I got to find it. I can actually either go between 5 and 6, or 3 and 5, or 3 and 6. What do you want to do here? 3 and 6? Okay. Or we can do 5 and 6 and 3 and 6. Let's do this one. So we're going to do A of 5 is approximately, right, v of 6 minus v of 3 over 2 minus a -4. Okay. What do you think? What did I do wrong? Oh, shit. Oh, sorry. I'm recording myself. No, I don't know why. I'm really not this dumb. What is it supposed to be? 6 minus 3. Sorry. Now I have this added anxiety because even though I don't always look at my notes, I don't have the right notes up here. So now all I can think about is I'm about to mess something up and then I do something stupid like that. At least it's on the dumb stuff. All right, so then what numbers go on the top? 2 minus a -4, right, over 6 minus 3. Now, do we actually care what the number is? The number itself doesn't matter, right? Is this going to be positive or negative? It's going to be positive, right? So A of 5 we're going to say is positive because we don't really care what the actual number is. We just put this one because we knew what it was, right? Otherwise, we could do a sign chart or look at a graph. And then, so is this speeding up or slowing down? Yeah, the signs are different, so it is slowing down. So particle is slowing down at t equals 5 because v of 5 is greater than 0 and a of 5, oh shoot, oh my god, it's less than 0. I might as well just stop. It's less than 0 greater than 0. You could also just say that they have different signs. You have to be careful sometimes when you just say different signs, because whether it's changing from positive to negative or negative to positive depends on, tells us some things about other stuff. So, but in this case, it's just that they're different. Okay, we good with that? Okay. So I'm going to skip that. We're going to go to these. Yes, I like these better. We'll come back and do the rest of it. Oh, let me give you the second page. We're going to take 2 days on this anyway. Okay. It's hot in here. Girl, get off your phone. You already have that? Or is that just the notes? Yeah. Yeah, this is the second set of notes. Okay. Yeah, there's a bonus. So this, we're going to put this on the same page. What page was it? 45. Okay. The graph below represents x sub a of t and v sub b of t. So we have 2 particles, position versus time of particle A, and velocity versus time of particle B. The graphs look identical. They are telling us something different. We have 2 particles that are either going left and right or up and down. Okay? So this is position versus time. Position. Oh my God. Y'all are going to kill me. Time goes on here. What the heck? This is time and position. Time is always your x. Position is over here. I know y'all probably lost all faith in me by now. Time, I just can't tell y'all. This last week, my brain has not been helping me at all. Velocity. I'm not as dumb as you think, I promise. Okay. Whew. Okay, so at each time, which direction is the particle moving? And explain your answer. Okay, or at 1.5, which direction is each particle moving? Okay, so this tells me position. Does position tell you which direction you're going? No, because if I'm moving left and right on something, I could be anywhere. Whatever my position is, it doesn't tell you what direction I'm going. What tells me what direction I'm going? Velocity. So at 1.5, right here, my position is negative. That does not matter. What matters is my velocity. Velocity is the derivative of position. This is my velocity, right? It's the slope. That's a this is particle A and this is particle B. 2 different particles. So particle A at 1.5 seconds, is it moving to the right or to the left? To the right, okay? So particle A is moving right at t equals 1.5 seconds because b sub a of t, right? Because this is x sub a of t. When we found the derivative, the slope, that's the velocity. And we can say is positive. Or you can say is greater than 0, either way. Whatever floats your boat is fine. Okay, sorry about all the extra stuff. Any questions on why? Do you understand what we had to do there? Okay, so tell me about, so let's say particle B, let's just go ahead and start it. Particle B is moving, which direction? What do you think? Oh my God, I can't even spell moving. I need to just quit. I'm going to turn in my resignation. Okay, so this is the time versus velocity graph, right? At 1.5 seconds, what's the velocity? Is it positive or negative? It's negative. This is time versus velocity. My velocity is clearly negative. Make sense? I'm not looking at the derivative of it because this is the velocity. That's why you need to label your graphs. That? So it is moving left at t equals 1.5 seconds because v sub b of t is negative or less than 0, however you want to say it. Okay. Any questions at this point? All right. So at t equals 4 seconds, particle B is it speeding up or slowing down? So when we're looking at that, is it speeding up or slowing down? We have to look at velocity and we have to look at acceleration, right? So we can go ahead and say, and this is a velocity sub b of t, well, actually, I guess of 4 is blank, and a sub b of 4 is blank. Okay, so we're going to say those two things. We're going to figure those out. From the graph, at 4, what's true about the velocity? Is it positive or negative? It's positive. Okay. And the acceleration is what at 4? How do I figure that out? Yeah. It's the derivative, which is the slope, which I can draw my little line. Does that line have a positive or negative slope? Positive. Okay? So those are the two things I have to look at. They're both positive. Therefore, how do I write therefore? 3 dots. Okay? Therefore, at t equals 4 seconds, particle B is what? What's he doing? Speeding up or slowing down? Speeding up. Because they're the same, right? Okay. What questions do you have? All right, read number 3. How many times does the speed of particle B equal 1? Speed. Are speed and velocity the same thing? No. Speed is what of velocity? Absolute value. Okay? So I want to know how many times the speed of particle B is equal to 1 or negative 1, right? So here's where it's 1. Here's where it is negative 1. So how many times does the speed of particle B equal 1? 4. 1, 2, 3, 4. You agree with that? This is when velocity equals 1. There's 2 times right here and right here where velocity equals 1. I don't know exactly what times there are, but do you agree with that? And then because speed is the absolute value of velocity, velocity could also be negative 1, because when I take the absolute value, it's 1, and there's 2 more times right there. And there's your 4 times. Okay? We good on that? Because it's not asking me when t equals 0, it's when v of t equals 0. So that's when you draw in those horizontal lines. Okay, so your answer there is 4. And then it doesn't ask me to explain it. All right. We're going to skip the calculator one for right now, because I don't have my, I think the next one is, we'll start this next one. Yeah, we're gonna do number 1 on this next one, and then I'm gonna give you your assignment. And we'll come back and finish these and do the calculator ones. We just don't have enough time to get out the calculators and everything. What is the initial position of particle y? Okay, so particles x and y are moving along the x-axis, so that time t, its position is given by blank. So initial position would be at time t equals 0, We have particle x and particle y. So that means I want y of 0. So that's equal to the cosine of pi times 0 squared over 4. That's a safe stop. Just so you know. We're going to finish it, but that's a safe stop. I have substituted it in. You do not have to simplify. This question is not testing your trig knowledge, but I'm about to test your trig knowledge, and you better not break my heart. But basically, that because I could not leave it with a 0, with a t in there, but I have substituted it in, right? This right here all by itself is a value of a number, right? And we're going to figure out what it is because it ain't that hard. But so you don't do something weird, you could actually stop. We good on that? All right, so that means that this really is just cosine of 0, right? What's cosine of 0? 1. Now, we haven't read the rest of the question. I may actually need this value in something. So I may need to do that, but guess what? I don't have to do it here. Because if I put 0 here, right? Let's say I put a 0 here. Then I'm going to get this whole thing wrong. Whereas if I just stopped here, I'd get credit for it. And then if down here I'm like, you know what, I need to know what that is, and then I figure out that it's 0 and use my 0 wrong, then I still got credit up here. You with me on that? So sometimes when you have to simplify. But all right, we are going to stop here for today because I don't want to get into anything else.